I'm also going to walk with you through one of the first application questions here, okay? Notice this is still applies the same rules, moving to the left, moving to the right, particle changes direction, all those rules that we talked about earlier in trimester 2 still apply. The only difference in this particular case is now when we're dealing with our functions are going to have exponential functions and logarithmic functions. So we're still doing the same rules, just with different functions, okay? So let's take a look at the first application question together. Here it's giving you the velocity. Remember, the velocity is the rate of change of position, okay? And it's moving along the x-axis and is given by this function here. V of t is equal to e to the t minus t e to the t. The first question says, determine the time at which the particle changes direction. Remember, when a particle changes direction, the velocity must equal to 0, but it also must change signs, right? Either from positive to a negative, or it could also be from a negative to a positive, but the velocity must change signs, okay? If it doesn't change signs, then it's just continuing to go in the same direction, momentarily stopping, and then continuing in the same direction again. So in this particular case, we're looking for when our velocity, or when v of t, equals e to the t minus t e to the t, right? When does velocity equal to 0? If that's the case, if we set this equal to 0, notice that both of these terms have e to the t. So why don't we factor out that e to the t, and we're left with 1 minus t equals to 0. Okay, if we set this equation equal to 0, as we already see, and we take each factor and set it equal to 0, we have either e to the t will equal to 0, or 1 minus t will equal to 0. If you think about the first equation that we have, e to the t equals 0, recall that e to the x, exponential function here with no transformations, that graph will never be equal to 0. So this one here has no solutions. However, this will be when t is equal to 1. Once we have where the velocity is equal to 0, recall that we have to justify that it actually changes signs. So we can go to our number line, and on our number line, we will have the value for time, which is at 1. Recall that when we're dealing with motion, for the most part, time usually starts at 0 unless otherwise indicated in the question. And all we need to do is we need to check the sign for velocity. So why don't we use some value like t equals to 1/2, right? We can look for v of a half. If that's the case, that's e to the 1/2 power times 1 minus 1/2. I'm just using the factored form. E to the 1/2 will be a positive number, and 1 minus 1/2 will also be a positive number. That means that velocity will have to be positive on that interval. We can also use a value for t that's larger than 1, like 2, and we can look for v of 2. This would be e to the 2nd power times 1 minus 2. Again, positive term times a negative term will produce a negative term. So therefore, the velocity there would be negative. You can see that the velocity does change signs at t equals 1. So therefore, that means that the particle will be changing direction when the time is equal to 1. Okay. In part B, they're asking you for an expression in terms of t for the acceleration. Recall that the acceleration is the derivative of velocity. So if I have that the velocity is equal to e to the t minus t e to the t, we're just going to take the derivative of that expression, okay, for the acceleration. Remember, acceleration is the derivative of velocity. So let's start with the first term, the derivative of e to the t. That's just going to be e to the t. It's the next term that you have to be careful of, and the only thing you have to be careful of is that you're not going to be sloppy with the negative sign. So let's bring down our negative sign, but let's use parentheses to show that we're taking the derivative of t times e to the t. So we're going to have the first times derivative of the second plus the second times derivative of the first. Now with that times 1 at the end, you don't have to write that, right? It's kind of redundant. Times 1 doesn't do much for us. So I'm just going to close off the parenthesis before I write that 1 for the t. Note here with this negative sign, let's take it and let's distribute it, right? The negative 1. So we have that acceleration, or the derivative of velocity, is equal to e to the t minus t e to the t minus e to the t. Note that the first term and the last term will add to 0. So that means that your derivative of velocity, or your acceleration, is a negative t e to the t. Okay, that is an expression for our acceleration. So acceleration, a of t, is equal to negative t e to the t. Okay, that is your answer for part B. For part C, they're asking if the speed of the particle is increasing or decreasing at time t equals to 3. Remember, okay, when you're talking about speed increasing or decreasing, that has to do with the signs of not just acceleration, and not just velocity, but acceleration and velocity together. So if acceleration and velocity have the same sign, so if a of t and b of t have the same sign, okay, that's going to mean that your speed is increasing. If your velocity and acceleration, so if a of t and v of t have different signs, that's going to mean that your speed is decreasing. Okay, so first let's find v of 3. Remember, v of 3, that's like having e to the third times 1 minus 3. Just using the factored form so I can get the sign really quick here without even using a calculator. We have a positive factor times a negative factor, and that will give us a negative number. So notice v of 3 is going to be negative. In addition to that, we can also look for a of 3, and using our function from above, that's going to be negative 3 times e to the 3, or e to the third power. Again, this is a negative factor times a positive factor, and that will produce a negative number. Therefore, acceleration and velocity have the same sign, and that means for us that their speed is going to be increasing. Okay, velocity and acceleration have the same sign. That means that their speed is going to be increasing. His speed is increasing. All right, and that takes care of the first application question. You're going to run through the last two application questions on your own, but just for a hint for number 2 to help you really pay attention to here, just make sure you read it very clearly. It says 2 particles are moving along the x-axis. So we have one particle P and one particle Q. Okay, the position of particle P, so note when you're dealing with particle P, they give you position, that is x of P. Right, so they're giving you the position for P. So just note anytime they're asking you questions about particle P, note that they started you with the position function, not with velocity, not with acceleration, but with position. So keep that in mind. In addition, as you're reading and it says particle Q, note that they gave you the velocity, okay, the velocity of particle Q, and that's that function there. Okay, they gave you the velocity. So again, as you're answering questions about particle Q, keep in mind they didn't give you position, they didn't give you acceleration, they gave you velocity. Okay, and then you should be able to answer questions A, B, and C from there. Also, guys, if you have seen, in addition to us posting this classwork today, we've also posted your first test for trimester 3. This is a week-long project, so you can take a look at that file. It will be due next Monday at 8:05 a.m.